Assalamu alaikum. Today I will discuss about the atomic absorption spectrophotometry. So here's the introduction of atomic absorption spectrophotometry. It is an analytical technique used to determine the concentration of metal atoms, ions, or metalloids in a sample of interest. Atomic absorption spectrophotometer measures the amount of light absorbed by the atom at their characteristic wavelengths. So here the discovery of the uh, of that method. The modern form of this technique was largely developed during the 1950s by Alan Walsh and a team of Australian chemists working at the CSIRO division of chemical physical physics in Melbourne, Australia. Where is the detectable elements by AAS? So what's the principle of that method is the principle of the atomic absorption spectrophotometry. AAS is based on the interaction of atoms with light at the specific wavelength. When atoms in the gaseous state absorb light at this specific wavelength, they undergo electronic transition from low energy state to high energy state. This absorption of light is directly proportional to the concentration of the element being analyzed in the sample. So instrumentation following are the key components of an atomic absorption spectrophotometer: sample holder, atomizer, hollow cathode lamp, and monochromator, detector and processor calibration. So here is a schematic diagram of a typical atom absorption spectrometer. We have hollow cathode lamp and atomizer, monochromator, sample nebulizer, and detector and recorder. Introducing the sample. So depending on the atomizer, sample can be liquid, solid, or gaseous state. Thus, to introduce the sample in the system, following ways can be considered: nebulizer. In flame AAS, a nebulizer is used to convert the liquid sample into aerosol, which is then introduced into the flame of atomization. Auto sampler. Modern AAS instruments also have auto samplers that can handle multiple samples and automate the sample introduction process. Auto atomizer. Using an atomizer, the sample is converted into atomic vapors for analysis. Flame atomizer. The most common type of atomizer used in AAS is the flame atomizer. It uses flame to convert the sample into atomic vapor. Graphite atomizer. For more sensitive analysis of trace elements, a graphite furnace is used. The sample is placed on a graphite tube and the temperature is increased to vaporize the samples. Hollow cathode lamp. The HCl hollow cathode lamp serve as the light source in AAS. Each element requires a separate HCl. It contains the element of interest as a cathode and is filled with an inert gas at low pressure. When a high voltage is applied, the inert gas ionizes and the resulting ions accelerate towards the cathode, causing the emission of light to a specific wavelength characteristics of the element. Monochromator. After the sample has been atomized, the emitted or absorbed light from the HCl is dispersed into its component wavelength using a monochromator. It separates the characteristics wavelength of the element from other unwanted wavelengths and show accurate measurement. Detector and processor. The last one, like we have screen detector, on that all the results will be shown. So the detector in AAS is typically a photo multiplier tube PMT. The PMT measures the intensity of the transmitted or absorbed light from the atomizer sample. When the light is absorbed by the atoms in the vapor, it results in reduced light intensity reaching the detector. The PMT converts this light intensity into an electrical signal. So here we have advantages of AAS: low cost per analysis, easy to operate, high sensitivity and accuracy, specificity, mostly free from inter-element interface, wide applications across many industries. AAS is used in the pharmaceutical industry to quantify metal impurities in drugs and medicines. AAS well is used to determine the concentration of trace element in water, soil, and air samples. In clinical diagnostics, AAS used to measure essential trace elements in biological sample like blood and urine. AAS is applied in the food industry to analyze the content of essential minerals and toxic elements in food product and beverages. AAS is used to analyze the content of trace metals in crude oil, petroleum product, and other petrochemical samples. AAS is also used to determine the composition of metal and alloys.